So in this video we're going to continue on and we're going to find equations of tangents to curves. So in the last video we learned how to determine the gradient of a curve at a particular point, and now we can use this information to find the equation of the tangent which touches the curve at this point. So it might look something like this. So we've obviously got the curve here in red. We've got the point where we found the gradient, and that is the gradient of both the curve and the tangent at that point. So the first example then, we want to find the equation of the tangent to the curve with equation y equals x squared minus 3 at the point 2, 1. So the minute we see equation of a tangent to a curve, we want to be thinking about differentiation. We need to find the gradient of the tangent to the curve at this point. So again, the minute we're thinking gradient, we're thinking the derivative. So dy by dx here is 2x. Now, like we've said, the derivative is the gradient, so we need to use the x-coordinate of the given point here. We know that the gradient is 2x, so that's 2 multiplied by 2. So the gradient here is 4. So the tangent, you can see obviously is a straight line. So we need to find the equation of the tangent, which we would use the straight line equation for, y minus b equals m bracket x minus a. So we know that b is 1 here, y minus 1 equals the gradient, which we found to be 4, multiplied by x minus 2, which is the x-coordinate. So you can see a was the x-coordinate, b was the y-coordinate. Now we can expand those brackets. It's always good to expand them. We sometimes don't have to expand them for the marks in the exam and higher. However, it's always good to expand them to ensure that if we need any other working, that we have the equation in simplest form. So expanding the right hand side, we've got y minus 1 equals 4x minus 8. And finally, adding 1 to both sides of my equation will give me y equals 4x minus 7. And you can see there that I've got my equation now in the form y equals mx plus c. So I've got my gradient here, which is 4. So if you get to the final answer and that has changed, then you've done something wrong, because you know the gradient is 4 from over here, and we've got our y-intercept, which is negative 7. So that is our final answer. And if we just have a wee quick look at the graph here, now in the red is the curve y equals x squared minus 3, and then we've got this tangent y equals 4x minus 7, and you can see where that point of contact is. The point of contact was 2, 1, and you can see from the graph there that is where the curve and the straight line meet. So just now would be a good idea, before we go on with the second example, to copy this one down in your notes jotter. So pause the video just now and do that. Okay, welcome back. We'll have a look at example 2 now. So a function f is defined on a suitable domain by f of x equals x cubed minus 2x. Find the equation of the tangent to the curve, there should be a 2 in there, to the curve y equals f of x when x is equal to negative 2. So the solution then, again, we're starting with f of x is equal to x cubed minus 2x. We're finding the equation of the tangent to the curve, so therefore we need to differentiate to get the gradient at that point. So f dashed of x is equal to 3x squared minus 2. And we know that the derivative f dashed of x is also the gradient. Now it's the gradient at a certain point, and it so happens that that point has the x value negative 2. So the gradient is f dashed of negative 2, which is 3 multiplied by negative 2 all squared minus 2. So that gives us 12 minus 2, which is 10. So our gradient here is 10. Now, in order to find the equation of the tangent, we need the gradient and a point. So we've got our gradient and we've got a bit of our point. We've got our x-ordinate, but we also need our y-ordinate. So in order to do that, we need to take our original equation, f of x equals x cubed minus 2x, and we need to substitute in negative 2, and that will give us our y-ordinate of the point. So f of negative 2 is equal to negative 2 all cubed minus 2 times negative 2. That gives us negative 8 plus 4, which is negative 4. And that then corresponds to give us the point negative 2, negative 4. Now we now have all the information that we need in order to find the equation of the tangent to the curve. We've got our gradient and we've got a point. So y minus b equals m bracket x minus a. And we've got y minus negative 4 equals 10 bracket x minus negative 2. So y plus 4 is equal to 10x plus 20, expanding the right hand side there. And then we'll subtract 4 from both sides to give us y equals 10x plus 16. And that is our final answer in the form y equals mx plus c. So you can see again here, we've still got our gradient here, y equals mx plus c. The gradient was 10 and it's still 10 here, so we're on the right track there. These need to match up. And finally, we'll just have a wee quick look at the graph. So the red curve is the curve with equation f of x equals x cubed minus 2x. You can see our tangent here in blue, y equals 10x plus 16. And you can see the point of contact, negative 2, negative 4. Again, if you copy this example down in your notes before coming back for example 3. Okay, welcome back folks. So example 3, find the equation of the tangent to the curve with equation y equals the cubed root of x squared, where x is equal to negative 8. So similarly to the last example, we don't have a point, we've only got the x-ordinate. But the difference here is that we've got a radical sign in here. We'll need to deal with that before we can differentiate. So y equals the cubed root of x squared is the same as y equals x to the power 2/3. Now, again, we're finding the equation of the tangent to the curve, so we need to differentiate this in order to get our gradient. So dy by dx is 2/3 x to the negative 1/3. Now, before we even think about substituting anything in here, we need to get this negative and fractional index. We need to get rid of that. So dy by dx is equal to 2 over 3 times the cubed root of x. So you can see that because it was a negative index, it's moved on to the denominator, and the fractional index has, we can now express this using a radical sign. So the gradient, remember we are substituting in x equals negative 8. So the gradient is 2 over 3 times the cubed root of negative 8. Now the cubed root of negative 8, remember, is negative 2. And simplifying all of that will give us negative 1/3. So we've got our gradient. In order to find the equation of a tangent, which is a straight line, remember, we need the gradient and a point, but we only have an x-ordinate at the moment. So let's find our y-ordinate to get our point. So y was the cubed root of x squared, which is the cubed root of negative 8 all squared. Now, the cubed root of negative 8 is negative 2, and squaring it gives us 4. So we have the point negative 8, 4. And finally, we can find the equation of the straight line here, which is the tangent to the curve, using y minus b equals mx minus a. So substituting in, we get y minus 4 equals negative 1/3 bracket x minus negative 8. Now, expanding the right hand side, on the right hand side we'll get negative 1/3 x minus 8/3. and adding 4 to both sides. Now before I do that, I'm going to express 4 in terms of thirds as well to make life a bit easier here. So negative 4 is the same as negative 12 thirds. So adding my negative 12 thirds to both sides, I get y equals negative a third x plus 4 thirds. And that should be in orange as well there, just to denote the gradient was negative a third and it still is negative a third. And that is our final answer. And as always folks, we'll have a wee quick look at the graph. Y equals the cubed root of x squared in red, and then you can see our tangent y equals negative a third x plus 4 thirds here in blue, and you can see the point of contact negative 8, 4. So again, good idea to copy this down in your notes if you haven't done so already.